Let's continue our unit on solving quadratic equations. Last time we looked at how to solve a quadratic by factoring. Today we'll look at how to solve quadratics by using square roots. In this case, we're going to take a look at special types of quadratics that we can solve using square roots because it might be simpler and quicker, more efficient, and you like to do things more efficiently than having to factor every time. So here are some examples of ones that we can solve by taking the square root. It's just like solving an equation. Notice in the ones we factored, for example, we had an equation, for instance, like x squared plus, let's see, 2x plus 1 equals 0. Notice I can't solve this for x because I've got two instances where x shows up. So I had to split that up by factoring. And so I said, oh, it's x plus 1 times x plus 1 equals 0. And so x was either -1 or -1. So it's a double root. So factoring is the more efficient method in that one. Here, I've got x that I can isolate. So if I solve this for x, I add 24 to both sides. I'll have 6x squared equals 24. And then I can divide both sides by 6 and get x squared equals 4. And then I can take the inverse of squaring, which is the square root. When I take the square root of 4, I get plus or minus 2 because I have positive or negative root for that. So if I can isolate x and get it all by itself, why not do that? It works a whole lot quicker. So in number 2, I could add 128 to both sides. And then I have 8x squared equals 128. And then if I divide both sides by 8, when I divide those by 8, I get x equals, what is that, 16? Or x squared equals 16, rather. Square root of both sides, x equals plus or minus 4. Okay, so why don't you try that next one on your own, see if you can get the solution. So we're going to get x by itself. I add 13 to both sides, get 36. Take the square root, x is plus or minus 6. Now, the reason I include plus or minus is because those are both the roots. If we look at the graph, y equals x squared minus 36, and I want to find out when x is 0. Notice I have a positive and a negative root where my quadratic equation crosses and gives me a value of 0. And that's what it looks like graphically. So if we go back to our work here, let's try a couple more examples. So 4x squared equals 9. Notice I just have an x, so if I can get it by itself, divide by 4. X squared equals 9/4. And then I take the square root. X will be plus or minus. We're going to take the square root of a fraction. That's really the same as square root of 9 over, I don't want to do that. It's really square root of 9 over square root of 4, which when I simplify that down, I get 3 over 2, because square root of 9 is 3, square root of 4 is 2. So plus or minus 3/2. Okay? So if I do the same with number 25, divide both sides by, or number 2, divide both sides by 25, I get x squared equals 49 over 25. You should recognize those as perfect squares. I'm going to keep these as exact as possible. Sure, you could take that on your calculator and divide it down. But if we can keep it as exact as possible, it helps us as we simplify work later on. So plus or minus, square root of 49 is 7, square root of 25 is 5. So plus or minus 7/5. Okay? Let's say we're working on number 1. 3x squared minus 11 equals 7. I would add 11 to both sides. And I get 3x squared equals 18. Divide both sides by 3. And I would get x squared equals 6. when I take my square root of both sides, I get x equals, well, 6 isn't a perfect square, so it's plus or minus square root of 6, which if I look on my calculator, I can approximate that if I want to, and it would be approximately to the nearest hundredth 2.45. So it would be approximately plus or minus 2.45. So if we want an approximation, we can do that, or we could leave it in simplest radical form if we'd like to. Just depends on what we're looking for. So number 2, we'd subtract 4 from both sides, x squared equals 10. And we get square root. And when I take the square root of 10, well, there's no perfect square we can divide out of that. So it's going to be plus or minus square root of 10. If we want to approximate that, it would be approximately square root of 10. It's 3.16. It's the nearest hundredth. So either would be acceptable, just depending on what you're looking for. All right, so let's find some other examples where we can solve by taking the square roots. So anytime we see a square, we can take the root if there's just an x by itself. Okay, this would be a lot of work if we tried to expand this out, square this term, then multiply it by 6. Subtract the 42, try to get it equal to 0. So let's just get the square all alone. Let's divide both sides by 6. Reverse our order of operations. So we have x minus 4 squared equals 7. Now, this whole thing is being squared, so we need to undo that. So let's take the square root. So keep in mind when we take the square root, that eliminates the square, so we just have x minus 4. And this equals, remember when we take the square root, it's a plus or minus. And if we approximate square root of 7 so that we can get an approximated answer, square root of 7 is about 2.65. So plus or minus 2.65. So I know x minus 4 equals a positive 2.65. Or it equals a negative 2.65. So I get myself two equations now because I have two roots here with that quadratic. And now we're going to solve this down. So I add 4 to this side. So x is approximately 6.65. Or I'll add 4 to this one. And x will be approximately, what is that, 1.35? Double check on my calculator. Yep, 1.35. So we get those two solutions there. So why don't you try number 2, restart it when you're ready to check your solution. Okay, so in this case I want to get x by itself. I see x minus 6, then it's squared, then it's multiplied by 4/3, then we subtract 20. So reverse the order of operations, we add 20 to both sides. And then I need to multiply by the reciprocal here, 3/4. That gives me 15. And to eliminate the square, I take the square root. So x minus 6 equals plus or minus square root of 15. So I'm going to show you how I can get that exactly. So I added 6 to both sides because x minus 6 equals a positive square root of 15 or the negative square root of 15. So when I add 6 to both sides, I have x equals 6 plus the square root of 15. That's the exact value. Or I add 6 to both sides. I get 6 minus the square root of 15. Those are the exact values. I could approximate those if I take the approximation of the square root of 15, like I showed in the previous example. But if you want to keep it exact, we can leave that square root in there. Either answer would be acceptable, unless the problem asks you specifically which form to use. Okay, so here's how we can use something like this. So vertical motion follows a quadratic formula. H equals negative 16t squared plus v sub 0 times t plus s. This stands for the height of an object. T stands for the time. V is our initial upward velocity, and S is our initial height. So as the object is falling, as this penny is falling off the top of the Willis Tower, we want to know how long it would take this penny to hit the ground and smash into the ground because it's so big. So we can create an equation for that. And the way we'd do that is we would set up our equation using our vertical motion equation. And so the Willis Tower is 1450 feet tall. That would be our initial height. We want to find how long it will take the penny to drop from the top of the building. So we want to find when the height is equal to 0. So we want h to be 0. And this penny is dropping. This first part represents gravity. Gravity's pull on an object. Gravity pulls and it falls quicker and quicker and quicker. This thing is not thrown up in the air at all. This penny is just dropped, so its vertical velocity is 0. And the height we said was 1,450 feet was its initial height. So when we simplify this down, we get negative 16t squared plus 1450. And notice I've just got one t left in my equation. So I'm just going to solve for t. Subtract 1450. Subtract 1450. And what I get here is I get negative 1450 equals negative 16t squared. I'm going to divide by negative 16. And negative 1450 divided by negative 16 gives me 90.625. So if I have 90.625 equals to t squared. So I'll take the square root, and that'll give me t. So square root of 90.625 is about 9.52 plus or minus. But keep in mind that we can't go backwards in time. At least I can't. Maybe you can. So this is going to be, it'll take about 9.52 seconds to hit the ground. Okay, so why don't you try the second example. How long will it take an object drop from a 550-foot tall tower to land on the roof of a 233-foot tall tower, assuming that it's dropped, not thrown up into the air at all. So if we apply our vertical motion formula, we want to know when the height is 233. Our initial height is 550. Our initial vertical velocity is 0. So we plug those into our equation, and 0 times t is 0. So that's just going to cancel itself out. And we solve for t since there's only one t in the equation. Subtract 550. Then we divide by negative 16 and take the square root, plus or minus. In this case, we can't go back in time, so it's got to be the positive. So at about 4.45 seconds would take for that penny to drop from the 550-foot tall tower to the roof of the 233-foot tall building. Okay, so that's all we got for today. We learned how to solve quadratic equations by taking square roots. And we found that when we have just one x in the equation, we can get the x by itself by taking the square root. When there's multiple x's, we're going to have to use factoring, or one of the other methods that we'll learn in our lesson next time. So do the practice problems, and I'll see you in class.